After we understand the integer float, we are going to learn about more complex data structure, which is list. List, in the list class, we can create a list instance, and it stores a sequence of objects. So objects can be anything. It can be the integer, or it can be float, it can be string. And there is a sequence of references or pointers to objects in the list. So it can be a variable as well. So anything can be in the list instance. And elements of list may be arbitrary objects. Arbitrary, it means any object, including none. So in Python, we have none object, or it is similar like null, not available. So Python can define that kind of object. Lists are array-based sequences. If you understand array, then you can easily have an insight about list. A list of length n has elements indexed from 0 until n minus 1. In any programming languages, they will start the index from 0 until n minus 1. Only some programming languages use starting index 1. For example, if you learn R language, they use index starting from 1. Okay. And lists have the ability to dynamically expand and contract their capacities as needed. I will let you know what is the meaning by dynamically expand. So you can have more values, okay, or you can decrease the dimensions. Is dynamic. Now you need to understand that when we use this kind of data structure, it applies different characters. When you are using lists, we have this square bracket. I call it, this is a square bracket. When we have this symbol square bracket, it means it is a list. When we have no value at all, then it is an empty list. If we have any objects or any values inside of the square bracket, then it is the element of the list. We have red, green, blue, and the separator is a comma, then it is a list containing 3 string instances. We can create an instance by using list like this with the parentheses. So this is a constructor to produce an empty list by default. And this list constructor will accept any iterable parameter. For example, we have list hello. Hello is a string, and there are 5 characters. When we use list, it will produce a list of individual characters. It's ELLO. Let's see some example of this. I can use the square bracket The square bracket means, yeah, an empty list. You can create red, blue, green, and don't forget to close the list. It means I have 3 elements. We have red, we have blue, we have green, and all elements are string. And I want to access the element. Now, let's say I can say I want to make one variable named data. And this data contain the red, blue, green. Then I can access the data index 0 by using the square bracket. And the result will be the first element of that list. How if I want to see the second element? Then I can use the index 1 and it is blue. What is the third element? I can use the data 2 and it is green. What about data 3? It will be errors. The list index out of print because they know that the list has only 3 elements. If you go back a little bit to Java, whenever we have this array, you need to define how many rooms for the array. In Java, we have also another data structure, which is array list. So the array list is similar with the Python list. We do need to arrange the room, or we do not need to specify how many capacity for the array. It will be flexible based on the number of your data. I can make one instance which is an empty list from the list class. If I check this A, then it is an empty list. So the idea is the same. If you can specify like this one, yes, this one is also a list. Let's say I have this one. Yeah, it is the same. Okay. With the square bracket and in the beginning, it will be less effort to create the data. As you can see before, let's suppose I have the Python list will automatically separate each of the character. Now, for example, I put the list into a variable A. Then I can access the index 0 is the character H. I can access the index 1 is the character U, and so on. Okay, and this is about list. Now we are moving forward about the tuple. tuple is also a class, built-in class in Python. It provides an immutable or unchangeable version of a sequence, which allows instances to have an internal representation that may be more streamlined than that of a list. I will explain with example. The parentheses delimit a tuple. If you still remember, when we use a list, we use the square bracket. If we use the parentheses, it is tuple. Okay, please remember this one. It can be one of the questions in your review quiz. Okay, it is list, and then this is tuple. The empty tuple is just a parenthesis without any values. To express a tuple of length 1 as a literal, a comma must be placed after the element, but within the parenthesis. So you can see here, if I have 17, comma, then it is 1 element tuple. So if I have a tuple like this one, this is an empty tuple. If I have 17 like this, yeah, we can have this one, but it is not defined. So usually we have the comma to indicate that this is a tuple with 1 element. Now, I would like to explain what is the meaning by the immutable, because using this example, it will be easier for us to understand the immutable. Let's see, I have the variable a. What is a? Oh, it has been changed. Maybe I will make it a as the red, okay, and the blue and the green again. So actually you can just go to the upper cell and then execute again, but let me just use this one. And then let's suppose I have b with the parentheses. I can say this is a list, and I have another data, blue and green, with the parentheses. So it is a tuple. So both of them are the same. We have a sequence of data. We have a collection of data. Okay? It is a set of data. And you can access A0 as red. And then I also can access B0 as red. So what is the difference? Suppose I want to change the index 0 in the variable a with yellow. Yellow, okay? Then if I want to print the variable a, then you can see yellow has been added, or it replaced the first element. How about if I use the tuple? Let me change to ground. Then it goes to error. The tuple object does not support item assignment. So this is the meaning by the immutable. When you have a value, you cannot replace, you cannot change the value. Okay, so this is one of the good example to show the immutable. String str. The string literals can be enclosed in single quotes. Like this example, we have single or double quotes. You can see this is double quotes. And those are similar. They are the same. They are strings. In other programming languages, maybe like Java, you use the single quote as character. It should be only one character. But if it is double quote, you can have more than one character. In Python, it is flexible. Either you use the single quote or double. And a string can also begin and end with 3 single or 3 double quotes if it contains new lines in it. You can see here, print, double quote, double quote, double quote. Welcome to the GPA calculator. And please enter all your letter grades one per line, enter a blank line to design it the end. Double quote, double quote, double quote. So you can print anything. See? Welcome to data structure and algorithm class. This is the basic Python lecture. Hope you do well in this class. And then I will do the 3 double quote. Then Python can understand the string because we have 3 different lines. Then this will be printed in 3 different lines. Okay, so the key ID is only these 3 double quotes. Okay. Set. What is the meaning by set? Python set class represents a set, or it is a collection of elements without duplicates and without an inherent order to those elements. So first, the key point is without duplicates. And the second key point is no order. Only instances of immutable types can be added to a Python set. Okay. You know the immutable types. It can be a float, it can be a string. Okay. Therefore, objects such as integer, floating point number, and character strings are eligible to be the element of set. The frozen set class is an immutable form of the set type itself. So the frozen set is another kind of set. If it is a set, you can change. If it is a frozen set, you cannot change. So that's only the difference. And we have a new representation. We call it curly braces. If you use list, you have the square bracket. If you know tuple, you use the common parenthesis. Now we have the curly braces. This is to indicate set. If it is only a number, you can just put in between the curly braces or something like red, green, and blue. And this one, there's a rule. The exception to this rule is that this curly braces does not represent an empty set. Okay, so only this exception. So if you want to create an empty set, you need to use the constructor set. Now, maybe we can see some idea about if we have only red, green, blue, maybe you will not see any difference. But there is one difference with this result. The first is the order. How can we determine this order? I don't know. The Python make it as a random. Maybe you can say they start from the small letter B and then G and then R. I cannot make sure about that one, okay, because it is in the Python memories. Okay. Maybe this is only a coincidence. So what is the difference with the list? What is the difference with tuple? It seems it is the same. Let's say I have the C. Okay, and then I know the C. This is not possible. Okay. So we can see only the set of this one. And if we want to get the maybe I can show you another difference. Let's say I have A, which is a collection of A, B, and C. What is A? Then we have the element A, B, and C. What about if I make a C equals to A, B, and C? Oh, sorry. I need to make it as a set. Okay, this is list because we use the square bracket. I want to make it as a set. We use the curly brackets. If I run this one, then I can get C. What does it mean? Yeah, the duplicate. Okay. Okay, the duplicate will be deleted. We will only get one element. P are duplicated, so we get only one element. That's the meaning by the set. So if you want to check this element, yeah, we need to use the iteration. Okay? So I will explain later, not now. That's why we cannot access like this. You can access the A0. We know the index. If we are using this, we know that this is the first element, this is the second element, this is the third element, fourth and fifth element. But in the set, they need to check first whether there is a duplication or not. And after they know that some elements are duplicated, they will delete and they will make some kind of order that we do not know. So that's why we cannot do with the C like this. We cannot get the object. So we need to do the iteration. We will check later with the iteration. Okay, and the next data structure is about dictionary. Dictionary or DICT class, it is a dictionary or mapping from a set of distinct keys to associated values. Again, I will show you. If it is a list, we use a square bracket. If it is a tuple, we use parentheses. If we use the curly braces, it is a set. In dictionary, we will use also the same curly braces. There will be a difference between set and dictionary. So Python implements a dictionary using an almost identical approach to that of a set, but with storage of the associated values. If you have a set, you will just have an element or you just put the element. But when you use the dictionary, you will have the key and you have the value. The literal form of these curly braces produce an empty dictionary. That is the reason you cannot have these empty curly braces. It's different. Set and dictionary. The non-empty dictionary is expressed using a comma-separated series of key colon value. So this one, the key colon value. And it should be a pair. For example, the dictionary of, this one example, GA is Irish, GE is German. So I want to map GA to Irish and then I want to map DE to German. Maybe in our case, if you learn like the dictionary in Tabago, Google Translate, okay. Suppose you have school, okay, and you want to translate it to Korean, and it is you. Okay, then yeah, it is the same. We have the key. The key is school, and the value is Hakim. We can also apply some kind of different data structure to represent a sequence of key value pairs, and we call the dictionary class. For example, we have lists here, and then we use the tuple to indicate for every of this data, and we put this into dictionary. So we combine several of the data structure into dictionary. So let's see. Okay, I guess let's just use the example from the PowerPoint. Okay, you cannot use the ICT as the identifier. You cannot use this one for the variable name because it is a class name from the Python. So let me just use the ICT one. And I have, okay, let's use the same. GA represent the iris, and then DE represent the German. Let's suppose like this one. When you want to access the data, we cannot access the index. There is no index 0. There is no index 1. We need to access the key. What is the key? In this case is the first one before the column. So we can call this one GA. We can get the value. If we want to call the other key, then we will get the value German. So for this example, yeah, the dictionary, we need to call the key, and we will get the result of value. So in the PowerPoint, you see that there is a variable pairs, and we are going to apply with list. And inside of the list, we have tuple. So the tuple is GA, and we have iris, and the other tuple is DE and German. So it is a combination of the list and tuple, and inside of these pairs, I want to make it as a dictionary. So I can call the dictionary class, and I put the pairs inside of the parenthesis. It means I'm going to use this variable pairs as the parameter, and it will automatically create a new dictionary. Okay. Expression and operators. In Python, the expression is more expressive compared to other programming languages. So the existing values can be combined into expression using special symbols and keywords known as operators. The semantics of an operator depends upon the type of its operands. So if the common operand is the mathematical, like the plus, minus, multiply, division. So for example, when A and B are numbers, the syntax A plus B indicates addition. If A and B are strings, then the operator plus indicates concatenation. Five plus 7, you can get easily 12. Half plus Yongin, you will easily get half Yongin. Okay, so you don't need to define the data, so it will give you directly the result. 6 multiplied by 5, then automatically 30. 10 divided by 2, 5.0. What about 10 divided by 2 with double slash? It will give you the integer value. Okay, so this one is a float value, and this one will give you integer result. Let's say 10 divided by 3. Then the result is 3.33333. If I have 10 divided by 3 with double slash, so it will be an integer value. If I want to use another way, which is modulo, I can use the same operand, is the percent. So it is the remaining namoji. Okay. There are some logical operators. Python supports the following keyword operators for Boolean values: not, and or. In this case, not is a unary negation. So if it is not true, then false. If it is not false, then true. And an or is also another operator. Okay, if you use the if, maybe we can do this one more in the Python 2. In the slide Python 2, we will do more about these logical operators with if function. The and or operators short circuit in that they do not evaluate the second operator if the result can be determined based on the value of the first operand. Maybe the simple one is to see like 3 greater than 5 and 2 less than 3. Okay, so we can easily use the AND operator. I think I don't need to explain again. You know, false and false. What is the result? False and true. True and false. True and true. So that's the logic. Okay. So here 3 is greater than 5. False. Because we know it is false. So this one mentioned that they do not need to evaluate the second operand if the result can be determined based on the value of the first. Because the first is false, so yeah, of course it is false. If it is using n. And if you use or, it is true because 2 less than 3 is true. And if you use not 3, 5, it is the negation. Okay. Equality operators. The Python supports the following operators to test two notions of equality. Okay. Is means we have the same identity. Is not, we have different identity. Equal means equivalent, and not equal is not equivalent. The expression A is B equals to true precisely when identifiers are A and B are aliases of the same object. So the expression A equal B tests a more general notion of equivalent. Maybe I can show you sample. We know that if 5 equal to 5, we know it's true. 5 not equal to 5, it is false. This is the equivalent and not equivalent. Actually, we can also do with variable. Let's suppose A equal to 5, 6, 7, and then B equals to 3, 4, 5, 5, and A equals B. You can do like this one. You can check whether they are equivalent or not. Let's say I have C equal 5, 6, 7. A equal C. False. So A is 5, 6, 7, and then C is 5, 6, 7. Although the elements are the same, but they're different in the structure, so it is not equivalent. And A is C. Yeah, it is representing. It's not the same identity. Yeah. It's not. It's different identity. A is not C. It's true. So it is the opposite. The comparison operators, yeah, is the same with the other programming language. We have less than or equal to, greater than or equal to. Okay. And these operators have expected behavior for numeric types. And the good thing is it is also defining the lexicography. What is lexicography? It is based on the letters. And it is a case sensitive for string. Let's suppose, yeah, you know 3 greater than 5. Of course, it's false. What about if I have hello greater than hello? It's true. Why? Because we have the ASCII character. Okay? The ASCII character. Just want to give you some reminders. The ASCII character. It is the American Standard Code for Information Exchange. They use the characters. And the first will be the big letter. And after we have the big letter, we go to the small letter. So the number of the small letter will be higher. That's why it is true. Okay, and arithmetic operators. Okay, I have explained this one. Plus is the addition, minus subtraction, multiplication, division is true division, and then 2 slash means integer division. We want to get only the integer value. And then the percent is the modulo operators. For the addition, subtraction, and multiplication, if both operands have type integer, then the result will be integer. If both operands have type float, then the result is a float. The true division is always type float, and integer division is always integer. Can you understand the meaning? Okay. So let's see what example. If I have 5 plus 6, of course, integer. 5 plus 6.0. We have integer plus float. Then the result will be float. Of course, if both of them are float, yeah, the result is float. Bitwise operators. So this is a little bit complex to mention. In the bitwise, it is about the binary numbers. We have the bitwise complement, we have the bitwise with AND, we have the bitwise with OR, and bitwise with the exclusive OR we have shift bits left and shift bit right. I have one example actually to represent. Okay, because of the time, let me stop. Maybe I need more time to explain this one.